Hi, my name is Julien, and I'm a chemistry teacher at Bronx High School for Writing and Communication Arts. Welcome to my presentation, Chemistry Does Matter, Making Daily Connections. Bronx High School for Writing is one of 6 schools co-located in the Evander Childs complex in the North Bronx. We have 380 students, half of which are Latino, 45% are Black. All of our students are eligible for free lunch. A quarter of our students are special ed and 10% are else. I observed that a number of my students had difficulties with major chemistry principles and couldn't make connections of these concepts across units. They also weren't engaged in class. I identified 3 factors that contribute to these problems: abstract chemistry concepts, modular Regents curriculum, and lack of science resources. In chemistry, we attempt to account for macroscopic phenomena by examining submicroscopic substances like atoms and molecules, leaving students, well, confused. Furthermore, too much information is crammed into each unit in the curriculum, making it difficult to see the connections. Finally, the lack of resources provides challenges too. Many schools lack a fully functioning lab with adequate chemicals, equipment like glassware and hot plates, and a lab tech who can support experiments. These factors led to traditional teaching methods that was lecture-based with very little inquiry. These observations led to my problem of practice. How might we use lesson structures to increase content connections and student engagement? The democratic science teaching principles used were critical content literacy and shared authority. The solutions are to incorporate inquiry-based lab investigations, computer-based simulations and animations, and model building of science concepts. Students perform weekly lab investigations related to the topics we cover. They also make observations and gather data to relate to these concepts being studied. Students use chemistry apps like Collisions to learn about atomic structure and chemical bonding. They also use PhET simulations to build atoms and learn about subatomic particles. Finally, through model building, students construct unobservable structures to get a tangible sense of what they look like and their function. All of the learning opportunities are structured within the 5E learning cycle approach, where students engage, explore, explain, elaborate, and evaluate. They are provided with choices in which activities they want to do. During the exploration stage, students have a range of options, from conducting virtual experiments to watching videos like Khan Academy or animations like Brain Pop, playing science games like PhET or Collision, or building models. As a result of these interventions, there has been improved student performance, particularly in areas in atomic properties and trends in the periodic table. Additionally, the students are a lot more engaged in class. They look forward to doing labs, and they enjoy the chemistry games. Some of my teacher tips include administrative support to guide implementation, a means of acquiring the proper resources, setup time to put these structures in place, and a classroom management plan that ensures efficient use of time. To push my thinking, I'm wondering, how might I incorporate problem-based learning so that students can make deeper content connections? And how can I teach students to create procedures to investigate chemical phenomena? I'd like to thank the Junki Bazu Foundation and the SciEd Innovator staff for all of their assistance throughout this process.
Created using Powtoon.